All right, today's section is going to have a lot of vocabulary to it. It's going to have a lot of important notes in it. And so get prepared for that. It is from Module 3, Section 7 on parallel lines and transversals. And so transversal is not a new word for us, but let's make sure we understand what I mean. If I have a line that crosses through other lines, basically, then that's the transversal. And so to be able to talk about these angles that are formed, I need to be able to identify the transversal that they are all on. So all 8 of these angles lie along transversal T here in this picture. And so parallel is a different word that you should for sure know as well. And if you don't know, we use the symbol. I guess I should probably not use parentheses there. All right. We use a symbol like that. That means parallel, right? Parallel. So if I wanted to say here that line JK is parallel to line LM. Now, when you type, sometimes it doesn't always show up as like that slant like I just drew. It shows up more like you see down here with them straight up and down. It still means parallel, right? Parallel lines are never going to touch. They do not intersect, right? They're coplanar. They never intersect. And so that allows us to have some more rules with them as far as those angles along that same transversal. Okay. Parallel lines also, and I kind of skipped over it, parallel lines are going to be marked parallel by having these little arrows on them. As long as the lines have the same number of arrows, doesn't matter if it's 1 arrow or 2, right? Then they are parallel. All right, and so maybe here I'll have line L and line M. All right, and so L is parallel to M. Also, I could have a line going through it, and that would be T. So my transversal here would be line T. Right? Or maybe I have lines that go straight up and down, and then we mark them parallel. We have this goes here, and so I have these points A and B, and C and D. Right? And so line AB is parallel to line CD, but the transversal here would be line BD. Okay? So you got to be able to identify transversal. You also got to understand what lines are parallel, and that these little arrows indicate that they are parallel. Okay? So now we have these vocabulary terms. We need to be able to identify corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. The book will sometimes call same side interior angles consecutive interior angles. I'm going to almost always refer to them as same side, but it does not matter which words you use there. So corresponding angles. Corresponding angles are on the same side. One is on the interior and one is on the exterior. Interior here, all right? Exterior either here or here, all right? So inside and outside. Corresponding angles are on the interior and exterior on the same side. So like A is on the exterior and E is on the interior. I also say they pair up by location. So at this point, A is in the top left corner. At this point, E is in the top left corner. And so they're corresponding. Their locations correspond or match up. Right? And so what are my corresponding angles? A and E are corresponding angles. Or B and F. B being top right, F being top right. Or there's more corresponding angles. C and G. Inside and outside. Inside matches with the outside on the same side. They're both on that left side, right? Or you can say they're both in the bottom left corner compared to the point, right? And then D and H. So those are all examples of corresponding angles. Alternate interior, opposite completely, but they're also interior completely, right? And so C and D, no, not D. D is a linear pair. That's just a linear pair. We have that already, right? C and F. So they're both on the inside, but they're completely alternate of each other. Or D and E. And so C and F or D and E are alternate interior. Alternate exterior then would be the same kind of thing, but on the outside. So A and H or B and G. Same side interior is on the inside, but on the same side. So C and E or D and F. C and E or D and F. And again, those can be called consecutive interior, and they're going to be the weird ones today. So that was an example when the lines were parallel. If the lines are not parallel, these angles still exist. Now, we're going to use them most of the time when they are parallel, but the words still happen here. So give me one example of corresponding angles. Maybe you said angle 1, and what angle corresponds with angle 1? Angle 5. Alternate interior. Maybe I'll say angle 3. What angle is the alternate interior to angle 3? Also angle 5. Alternate exterior. Let's start with angle 2. Angle 2 is alternate exterior with what angle? Angle 8. And then angle 3 and angle 6 are same side interior. Now, obviously, there's more than one option there. You could have said 4 and 8 for corresponding. You could have said 4 and 6 for alternate interior. You could have said 1 and 7 for alternate exterior. You could have said 4 and 5 for same side interior. And I skipped 2 of the correspondings in just those ones. Right. So you try. Take a second, pause the film, and you try. All right, for 1 and 8, hopefully you got alternate exterior. For 2 and 5, hopefully you got same side interior or consecutive. Remember, I call that same side interior. Right. 4 and 5, alternate interior. 3 and 7, corresponding. And so now we have these postulates and theorems, and these are very, very important. So please write them down, right? It's okay if you, as long as you know they're all going to start with the lines are parallel. It's okay if you just get the end parts. But they all are based, so they all require lines being parallel. So that's a prerequisite for all of these rules, right? And so corresponding angles, if the lines are parallel, corresponding angles are congruent. If the lines are parallel, alternate interior angles are congruent. If the lines are parallel, alternate exterior angles are congruent. And if the lines are parallel, same side interior angles are supplementary. And these rules are going to be with us pretty much all the rest of the year. These are very important rules. Please get them down into your notes. We're going to spend a few days making sure we understand these. And so this down here kind of explains those rules. A corresponds with E, so they're going to be the same. C corresponds with G, so they're going to be the same. They're congruent. All right. B corresponds with F, D, and H. Alternate exterior, A and H, they're going to be the same. G and B, they're going to be the same. Alternate interior, C and F, D and E. Same side interior, C and E rather. C and E are going to add up to 180. D and F are going to add up to 180. One of the things I want to point out this time is if you know one angle here, I guess first, if you know the lines are parallel, so you know these lines are parallel, then if you know one angle, this is 100, well, sorry, I was going to write 60, but it's obviously obtuse, so 120. If that's 120, then this is 120 vertical angles. A and B are a linear pair, so that has to be 60 to have to 180. C then is 60 vertical angles. And now I can use all my rules. E is 120 because either you could say either that you saw that it is corresponding with A or alternate interior with D. And then H is 120. And now you could say that you saw that it was alternate exterior with A. You could say you saw it was corresponding with D. Or you could say you saw it was vertical with H. Right. F is 60. And so you could say you saw that because it's alternate interior with C. You could say you saw it corresponds with B. You could say same side interior with D because they add up to 180. You could say linear pair with H. They add up to 180. You could say linear pair with E. They add to 180. And then G is 60, and it just has a multitude. You could say alternate exterior corresponding. You could say vertical. You could say linear pairs. All kinds of reasons why G would be 60. Okay. So we got to name the transversal and tell me what kind of angles they are. So angle 3 and angle 5. Well, let's first find where's 3. 3 is right here. Where's 5? 5 is right here. So if I look at them as being in between these parallel lines, all right, then 3 and 5 are inside and opposite. And they're both on this transversal, which is M. So, all right, so the transversal is M, and they're both alternate interior angles. Where's 2? Where's 3? 2 and 3. So 2 and 3 are between this line and this line. All right. And they're both on this line N. So N is the transversal. All right. N is the transversal. And 2 and 3 are same side interior angles. All right. You could also call that consecutive interior. 6 and 7. 6 and 7. 6 is right here. 7 is right there. So they're in between or sharing these, and they're both on Q. So 7 and 6. Inside to outside. Top left, corresponding on Q. So Q and corresponding angles. Right. Darius is painting a geometric art piece using parallel lines. Lots of parallel lines there. They highlighted a few of them in yellow. Right. Angle 4 is 54 degrees. Right. And so angle 4 is 54 degrees. Right. And they want us to find angle 7 down here. If 4 is 54, 8 is 54, corresponding. So if this one right here is 54, it corresponds with 8. 8 is 54. And so now 7 and 8 make a straight line, so they add up to 180. All right, so I'm going to do 180 minus 54. All right. I get 126, and so angle 7 is 126. Where's angle 4? Angle 4 is right here. Where's angle 1? Angle 1's right there. Are they a match in any way? No. 4 corresponds to 2, though. All right? Or 1 corresponds to 7. And so if 1's 85, 7's 85. And this is a straight line right here. So 4 and 7 make 180. So 2x minus 17 plus 85 equals 180. So 2x 85 minus 17, right, is 68 equals 180. Minus 68 to both sides. And I get 112. All right. And divide by 2, I get x equals 56. And it says find x. I didn't plug back in for angle 4. I just found x. X was 56. Proof. Proof, step 1 of a proof always is the given. L is parallel to M. And the measure of angle 1 is 40. And that is given. And so let's mark this stuff now up in our picture. So these are parallel. And angle 1 is 40 degrees. Now I see that angles 1 and 2 make a straight line. So these two angles make a straight line. And so they're a linear pair. And I just saw that from the picture. All right. And so the measure of angle 1 plus the measure of angle 2 equals 180 because they're a linear pair. And then angle 1 was 40 degrees. So I'm going to plug 40 degrees in. So 40 plus the measure of angle 2 equals 180. I plugged it in, so it's substitution. I then do the math. I subtract 40 to both sides. The measure of angle 2 equals 140. All right? And I did subtraction. Now, if this is 140, these lines are parallel, corresponding angles are congruent. And so I know that the measure of angle 2 equals the measure of angle 3, right? Because they're corresponding angles. And that means that the measure of angle 3 is 140 because it's the same as 2, right? Because I just plugged 2 in, so that's substitution. And so I have proven that the measure of angle 3 is 140 degrees. Please give them a try, page 211, 212. Best of luck.